Hi everyone, it's me again, and tonight we're going to continue the series of problems that my students have identified. And this time we are still on quadratic equations. So I have done a couple of videos on, I think more than a couple on quadratic equations. So this would continue that series. So just to take a look at today's questions. This is from normal academic, but I think express students can benefit from this as well. So two questions. The current I ampere passing through a rheostat is given by the formula where V volts is the voltage, R ohms is the resistance, and in the circuit V is equals to 240. When the resistance of a rheostat is decreased by 20 ohms, the current will increase by 1 ampere. Find the original resistance of the rheostat. Next one is, of course, Abel and Sam ran a 42 km marathon. Average speed of Abel was x km per hour, and average speed of Sam is 3 km per hour faster than Abel. Expressed in terms of x, the time taken in hours to complete the race by both boys, and then their equation to be solved. Now, very quickly, let's go there now. Okay, so just looking at the formula, if I get my thing, I equals to V over V over R. So we can actually form two equations. Okay, initially when I equals to, let's say, 240 over R, this is the initial one, this is equation 1, okay, and then where I plus 1 equals to 240 over R minus 20. This is the second one. Now, how do I get the first one? She's actually given in the question. When V equals to 240, the unknown I and R is there, so we just assume that's I and R. But when the resistance R is reduced by 20, the current goes up by 1 ampere. So right now we need to look for the original resistance. So how do we find it? Now, there are two simultaneous equations over here, so we can sub 1 into 2. Okay, sub equation 1 into equation 2. Okay, so you have 240R plus 1 equals to 240 over R minus 20. So I have just substituted I equals to 240 over R into the second equation. Okay, so what I'm going to do, I'm going to make everything, I can just group my terms on the one side. 240 over R plus 1 minus 240 over R minus 20 equals to 0. Now, I need to make everything into a common denominator so that I can start working on it. So in this case, the common denominator will be R times R minus 20. Okay, so 240 over R, okay, times R minus 20 times R minus 20, okay, plus 1, this will be R minus 20 over R minus 20. This was the original term, the one term, okay, 240 times R over R minus 20 times R equals to 0. Okay, so what I've done is basically made everything into a common denominator. Okay, so with 240R minus 4800 plus R squared minus 20R minus 240R whole thing over R times R minus 20. Okay, and equals to 0. Now, since this is a fraction equals to 0, we can just care about the numerator. Let me see if I got everything right. Okay, so 240R minus 4008 plus R squared minus 20R minus 240R equals to 0. R squared minus 20R minus 4800 equals to 0. Let me just check if I got that right. Yes, I got it right. Okay, and then basically what we're going to do, we're going to factorize this. R minus 80 times R plus let me see, 60 equals to 0, and R equals to 80 or minus 60. Now we need to reject this term, okay, because a resistance would not be a negative 60. So therefore, original resistance was 80, I think amperes, is that right? No, 80 ohms. Okay, and that's how you do it. Okay, so what was important in this question is basically forming your two simultaneous equation on the left hand side over here. I equals to 240 over R and I plus 1 equals 240 over R minus 20. So I think that was the first step, the first crucial step that we needed to take to solve this question. So I think a straightforward question in general, but I think students generally have troubles getting the two equations out to start off with. Okay, moving on very quickly to the next question. They ran a 42 km marathon. Average speed of Abel was x km. Okay, so what is the average speed of Abel? Okay, average speed, okay, of Abel, it's distance over speed, okay, which is 42 km divided by x km power. So its average speed was 42 over x km. Sorry, this is time taken, so it's not 42 over x km power, it's 42 over x hours. Okay, yeah, it's 42 over x hour. Okay, and similarly for part 2, average speed, the average speed of Sam, okay, is distance over speed. Distance 42, same. Speed is he traveled 3 km per hour faster. So your speed is x over x plus 3, and he took 42 over x plus 3 hours. So easy does it. Now next one, for part B, Sam completed the race 28 minutes earlier than Abel. Form the equation in x. Okay, so Sam was obviously the faster one. Okay, so we want to say that we'll express it. This is the time taken for Sam to complete the race, and you minus 42 over x. This is the time taken for Abel to finish the race. Now, the tricky part here is it's 28 minutes. Now, everything on the left hand side, the average, the time taken is all in hours. So we need to express 28 minutes in terms of hours, okay, which is 28 over 60, which when you reduce to the lowest form, okay, is 7 over 15. Okay, so 42 over x plus 3 minus 42 over x equals to 7 over 15, where 7 over 15 is 28 minutes expressed as an hour. Okay, so I think it's going to be straightforward. What we need to do, we need to express both sides in terms of a common fraction, a common denominator. Okay, so on the left hand side, 42x minus 42x plus 42 times 3 over x squared plus 3x equals to 7 over 15. Okay, so that's the very first step that we did. Okay, so 42x minus 42x 0. 42 times 3 is 126, if I'm not wrong. Okay, 126 over x squared plus 3x equals to 7 over 15. Okay, I think so. I hope so. I hope my calculation is right. Okay, and then we're gonna cross multiply. Okay, so 126 times 15 equals to 7 times x squared plus 3x. Okay, so we get let me see how it's 1890 equals to 7x squared plus 21x. Okay, now bringing everything to one side, 7x squared plus 21x minus 1890 equals to 0. And then if you divide the whole line by 7, you get 3x squared minus 2 something, 270 equals to 0, which is what you are required to show. Okay, Ken? I think it's easy. What is hard is finding, expressing 28 minutes as an hour. I think that's the tricky bit. Okay, next one, solve for x squared plus 3x minus 270 equals to 0. I think in this case it's easier to use x equals to minus b plus minus the square root of b squared minus 4ac over 2a. Okay, minus b in this case minus 3 plus minus 3 squared minus 4ac is minus 270 over 2. Okay, and then if you get your answer, will be 15 or minus 18. Okay, we need to reject minus 18 because x is a speed in km power, so it cannot be a negative speed, so therefore x equals to 15. Now find the race time of Abel. Correct your answer to the nearest hour and minute. Okay, the speed of Abel was 42 over x, so this is D. The time taken for Abel. Time taken for Abel equals to 42 over x. In this case, 42 over 15. Okay, which is equals to 2/4 hours, which will get 2 hours and 48 minutes. Okay, it's a simple matter of substituting in x value. Now I think I spotted a mistake over here. Yeah, if you haven't spotted a mistake yet, it's good. There's a statement mistake here. This is wrong. Okay, it's not the average speed. Okay, this is not average speed, it's time taken. Time taken for Abel and time taken for Sam. Okay, I apologize for the careless mistake, but all other workings remain correct. It's just a matter of a statement. So once again, 2 questions on quadratic expressions and how we can use the rules to solve them. I hope you have found them useful. Comments and suggestions welcome as always. Thank you very much.